In this video, we'll be taking a look at some tips and tricks for designing sheet metal parts in SolidWorks. If you're new to sheet metal, make sure to check out our SolidWorks sheet metal quick introduction video, which covers the basic concepts and features to get started. When modelling in SolidWorks, it's important to choose the best profile to start with, and the same applies when using sheet metal tools. Take a look at this example. Using the base flange method, there are two approaches that could be used to model the part. An open sketch profile could be drawn, with the sheet metal thickness being offset about the sketch and the length of the part extruded. This would leave the detail of the chamfer and the holes to be added as separate features. Alternatively, the profile for one of the flanges could be sketched first, with the sheet metal thickness being added perpendicular to the sketch plane. This would leave the additional bends to be added as edge or mitre flanges. This is just a simple example, but choosing the best profile can save a lot of time and also make the model easier to modify at a later stage, as it determines where key dimensions appear. The Edit Flange tool allows a bend to be added to the edge of a sheet metal body. The default is that the flange will be rectangular in shape and run the entire length of the selected edge, but sometimes there is a need to modify the geometry of the flange to create a different profile. This can be achieved using Edit Flange Profile. Clicking Edit Flange Profile enters sketch mode for the flange. From here, any part of the sketch can be adjusted, such as the position or offset from the end of the selected edge, additional material being added, or holes being captured at the same time. Because the sketch has been modified, some of the values in the edge flange properties are no longer linked, so it's important to define the sketch as you would for any other sketch by adding relations and dimensions where needed. Sheet metal parts are usually profiled using a laser or plasma cutter before being bent into shape. These methods cut the material perpendicular to the flat sheet, resulting in a cut face that is 90 degrees. Because this is how sheet metal is manufactured, it's important to ensure that models are created in the same way to avoid issues further down the line. When removing material from a sheet metal part using a cut feature, normal cut can be enabled within the properties. Normal cut ensures that any cut faces will be perpendicular to the flat sheet when unfolded, and therefore can be profiled using a laser cutter. Normal cut may need to be disabled for holes that are being added outside of the laser cutting process, such as a drill hole that is going to be added after the part has been bent. This type of hole does not have to be perpendicular to the flat sheet. Adding cuts across a bend can be achieved whilst the part is in a folded state, but it can sometimes be difficult to get the required cut shape. Adding the cut whilst the part is unfolded instead allows more control. To unfold a sheet metal part, click Unfold on the Sheet Metal tab. A fixed face can be selected and either a single bend, multiple bends, or all bends can be selected to be unfolded. Once the bends are unfolded, the cut features can be added in, and then the fold feature is used to fold the part back up. It's important to use fold and unfold, as both these get added to the history in the feature manager. Although the flat pattern button looks as though it's achieving the same thing, features are not added in the same way, so you won't get the cut that can then be folded back up. It's common to need to add cuts that only pass through the sheet thickness once. Rather than having to manually specify a blind value or pick up the surface each time, when adding a cut to a sheet metal part, an option called Link to Thickness can be ticked. If the sheet thickness is then changed, the depth of the cut will change too. For instances where a 2D drawing is not needed, but the sheet metal part still needs to be sent to the laser cutter, export to DXF can be used directly from within the 3D model. Right-click on the sheet metal body or part and choose Export to DXF DWG. In the Properties pane, select Sheet Metal under Export, and then more options will become available to control what information will be saved into the DXF, such as hidden lines, bend lines, and sketches. The output is a one-to-one flattened 2D file which can be then used for manufacturing. Great, that brings us to the end of this tips and tricks video. I hope it's been useful. Make sure to let us know if you have any ideas for other topics we can cover in future videos, and remember to check out Cadasio to start creating engaging 3D interactive presentations from your SolidWorks CAD data.